Hi, my name is Ilyas. I'm a senior data scientist within Vedrai. In Vedrai, my job is like assisting data scientists to make machine learning models and also to build like some workflows that can be scalable. So beside my job, I love working with startups. So I'm a startup lover. For me, it's like a kitchen, so it's like cooking. For this reason, I love also cooking. And I love also playing football. It's kind of sport for team. And in the same time, I love also making science memes because I think is the best way to simplify some difficult concepts. So in this presentation, we have a lot of fun because there is a lot of memes. So. Vedrai is a startup that is born 2 years ago in Milan, based in Milan. Have a mission to democratize and to standardize also the AI solutions for small and medium enterprises. Because we think that AI have a lot of benefits for enterprises, but the problem with small and medium enterprises that they have some limitation in budget and also expertise, especially for the enterprises that they are doing manufacturing or e-commerce or something like that. So we think that our mission is to help them, to give them the solution, the cutting-edge technology solutions in AI, and to democratize this solution for everyone. This is for the serious people. Like, if you follow us in LinkedIn, you will see this thing. But if you are not that serious, you can go to TikTok, and we have lot of things that they're really fun. So we try to help like the generation Zeta to understand exactly the machine learning, because for them it's kind of no natural intelligence, and it's important also to explain how it works in some simple use case. So if you are not that serious, you can go to TikTok. The solution that we propose is to provide to some responsibles in the enterprise some data-driven decision that can help them to take the support from data. So we have 6 core solutions, from CEO to the supply chain manager. And we give all the solutions that can be used from external data to internal data of the client, like, for example, forecasting the EBITDA, or maybe for giving some insights from social media, and also forecasting some sales forecasts for some products, and so on. So for more information, just go to our website, and you can see more details about the solutions. So this talk is organized as the following. So in the first part, I will talk about the challenges that we had in the past in Vedrai when we start developing a lot of machine learning models, because developing a lot of machine learning models required a lot of infrastructure, required that we should be scalable, required that handle a lot of volume of data, required check the quality of the data, because our clients, they are not that good with technology. So we work with small and medium enterprises. And this result, that the data that we have, it's provided in Excel from our clients, major part. So we need to check the quality each time the clients provide some version of data, and I also need to check my laptop for not working. Okay, now it's working. For these challenges, we provide some solutions, and they are the following. We'll see it after. I don't know which is working. And then I will present some conclusion about the work that we did for 1 year. So basically, this is also one of these problems. So maybe can go on, and then.
If you can, that'd be brilliant.
Yeah. So basically, the problems that we have as data scientists is the life cycle of the model of machine learning, because we have lots of steps, and it's not all the time straightforward. So, and Maybe I can try mine. Maybe I can try mine. I have like a jail's computer, so
Wow. That's huge.
maybe it's from the other part. So okay.
Go ahead. Oh, sorry.
Okay. Oh.
Now it's working.
Okay. Three, two, one. Okay. So how I say like that, one of the difficulties that we have like data scientists is to handle the life cycle of the development of the machine learning models, because it's not straightforward. It's not like software engineering that you have only one code and you should handle it, and you need to or fix some bugs or add some features or something like that. We have also data to handle, so handling data is more difficult than handling code. And all of that, if I can give some observations, starts from the raw data. So we have some data injection tools that inject the data as raw data, and then we need to make some pre-processing steps, some data cleaning, removing some outliers, making some standardization, something like that. Then we bring this cleaning data, new data, to our machine learning models. Then in the step, we need to search for the best model, for the best parameters, for maybe sometimes for the best group of models. And then when we found like our best solution, we need to deploy it to the server. Each time the version of data change, we need to do all this cycle. So we know that in the part of raw data, sometimes when we start like doing some ingestion, the code fails, and this issue is have like the problem of scalability. So for this reason, we need to be scalable in this step. For the data preparation step, we need to be also scalable because we have some ETLs that runs, and also some parameters that change. For example, the name of columns, the choose of the features, the threshold of the outlier, something like that. For the part of training, we have scalability. We need to be scalable because we need to train lots of models, and we have also some timing there, limitation of timing, and we need to search for lots of parameters of the best model, and also the best solution that we can provide. So we need to also do also some tuning. And for the last part of deployment, we need to be scalable, and because this is exactly where the inference of the machine learning starts. And we need to be lot of scalable because we have lots of users, we have lots of robots that ask for predictions, and we can't like make some errors in this part, or like turn in 500 errors. So we can't like do this error. Everything needs to be governed by machine learning governance standard, and for this, if I can say, we can like summarize the problems that we have. The first one is that the development of the models, they are really slow because they are not straightforward. The second thing, we should like reproduce the same results of the model everywhere, and this is other problem. The infrastructure needs to be scalable. The experiments should be tracked and monitored, and this is really important for the governance part. And we should let data scientists focus more on the data and the models, not in the operations and the data pipelines, because they spend lots of time there, like about 80% of the time in operations, and we need like to give them this time back to make more things important. And in the last slide, in the conclusion, I will show you exactly what our data scientists did with this free time. So for the solution that we proposed in Vedrai is based on two parts. Like the first part is introduce MLflow as a framework for handling the life cycle of machine learning. And the other part is to use a scalable infrastructure with some serverless services. We have Amazon-like provider, cloud provider, and the choice of serverless services is really important because we don't handle the servers. So data scientists do not have like some problems with servers or scalability or elastic serving, something like that. So we don't have this kind of problem. So having these tools help us to define three parts of the solution. The first one is how to make the development 10 times faster. And the second solution, how we use MLflow to make the governance part, and how we develop our architectures or our infrastructure to be scalable. So let's start from the first one. So the methodology to make the development 10 times faster is to use Kaizen ML. Kaizen is like a Japanese word for better improvement. And this is what we did. So we don't like waste time to make our best model to put it in production. So we start doing that. Okay, we have some model. It's not the best one. Just put it in production. And then we can make some improvement each time in some incremental work to put it into production. And each time that we make some improvement, we search to automate all this process. So we start by automating the data engineering part, then the continuous integration, continuous delivery, and then the auto-scaling part. And at the end, we found ourselves that we made MLOps methodology within the company without having already a plan to make it. So what is MLOps? So why is it different than DevOps? So in DevOps, we need to handle only code. But in MLOps, we need to handle the versioning of code, but also of the data. And I made this meme to exactly illustrate the problem of MLOps. So machine learning model is nothing than ejecting data in code in some way, to explain it more simply. To handle the versioning of data, we worked with DVG. That is a tool that interpret data as code. So once you have interpreting data as code, you can do the same things that you can do with Git for code. So you can pull data, push data, have this set of the version of data, and then you can simplify the versioning of data in this way. Once you can handle this versioning of data, you need to also ensure that changing from a data version to another one don't bring also some surprises or some bias, for example. This is important, for example, in kind of COVID. For example, one of our clients that have online platform and do sales forecasting. When it started COVID, he got a lot of transactions because people start to acquire to buy from online, and then changing the version from last version like of data to the new version of data with COVID, it changed a lot, and we didn't like monitor this part, and as a consequence, the model that we already developed in production didn't respond to the same inference or the same accuracy. And evidently, it's the right tool to make that. We use it just to monitor the data drift for the features and the target drift for the model target. It provides also as an output HTML pages, dashboard, that can be used also by people that they are not coders. So this is how we handle the versioning of data and the difference from a version to another. For the code part, we start to using the same pipeline, standard pipeline of continuous integration and delivery that's used our DevOps, with only one difference, that we use cookie cutter data scientists is a nice repository when you can have like a cookie cutter of the project that is focused on data science when you need to handle only 4 parts of code: the making of data set, the building of the features, the training of the models, and the prediction. So in this way, we made the machine learning, development of machine learning really fast. So we went from 3 months to put the features in production to 2 weeks, 3 weeks, as our front-end and back-end developers did. So we were very, very happy to make that. For the governance part, we used MLflow framework that handled the life cycle of the model. So MLflow have like 4 parts. The tracking part is the most important one because it provides user interface. You can see all your experiments, all the runs that you did, or other data scientists did, and you can use it in the code very easy. So we need only to put these logs as one row of code to log everything that you have as parameters, as metrics, as artifacts, as model itself in the server. The other parts of the server, MLflow server, we have user interface and artifact store and backend store, backend database. So we used S3, AWS S3, that is a nice storage that can scale to 5 terabytes. So we didn't have like problems with scalability to put all artifacts that we have. For the backend, we used Postgres based on AWS Aurora, that is a scalable relational database. So, and we will see exactly the architecture that we made in this part in the next slide. So in this way, we can track all the experiments that data scientists in each stage with each version of data. So it was like a nice thing that we provide. The other component of ML project is that you can have like the configuration of your project as a YAML file. So you can deploy it everywhere without problems. You can have it for Conda, for in this example. You can have it also for Docker, for virtual environment. So it depends about the tools that you are using while developing. There is also MLflow models. That is one of the things that I like really about MLflow. So you can have also some flavors about your models. MLflow models is nothing than saying that my model have this format. For example, scikit-learn have this format. TensorFlow have this format. Keras does have this format. Prophet has this format. Sarima have this format. So in this way, you don't need to have some problems in deployment, because once you have the MLflow projects that provide you the dependencies of the projects, so it's kind of container, that you put it in the production, and then you put the flavor of the model, so you don't have any problems. The last component is MLflow registry. So it's a new feature of MLflow. So in this component, you can register your best model that you choose, maybe by clicking or using APIs, in different stages. So each time that you code change or your data change, you do the training, then you put a new version in MLflow. This version should be registered in one of these stages. And then this part is manually, because in our case, we can say that the best model is the one that have the best F1 score, for example. Our best model is maybe the one that have F1 score, but also that we can explain with CHAP or some kind of explainative machine learning tools. And then this part is manually, so we can tag each best model in each stage, and we can test it, prove it before putting it into production. So it's like registering Docker. It's the same thing. So in this slide, I can show you the whole life cycle, how it starts. So in the beginning, we have lots of models, flavors, depends about the choice the data scientist made. This flavor or these models start to train in some servers, and then automatically log all the parameters, the metrics, and the artifacts models in the tracking server. From the user interface of the tracking server, the data scientists can put the best model that everything in the right stage. And once we are here, we can serve our models to production. So in this way, we can handle all the life cycle without problems. OK, so we make the development faster. We handle the governance part of the model. What is missing is to make all the infrastructure scalable. So it is important to make everything work fine. For this part, we provide some solution that is based on AWS components, that they are mostly serverless services. So this architecture is based on S3 for artifacts, S3, and Postgres as a backend. And MLflow doesn't have like the authentication part. So we made a proxy with Nginx for the login. We made Cognito for authentication data scientist. And then all the solution run on HER, that is Elastic Container Services that use Fargate as a service for serverless parts. So we don't manage any service. We don't manage any server. And this is fantastic. And we made all the YAML or the CloudFormation file to deploy the same architecture in other organizations, public in our repository in GitHub. So I need only the permission of our CEO to put it online. And then you can use the same architecture that we have in 15 minutes in your organization. For the training part, we made it in this way. So we have data scientists back and the trigger that post a train with some configuration. The train, if it is authenticated with Cognito, went to the API. The API invokes the function that is workflow of functions to start the training models. All the training is made in batch job that is based on Fargate, and then monitor in real time all the metrics, models, artifacts to MLflow. And then when it starts the job training, it pulls a Docker image that we already have in repository. So in this way, the data scientist doesn't need to do anything apart sending a post request from its Postman software. So this is nice. We have handled the training. We handled the development. So, but how we can like make also the inference part scalable? So we introduce Lambda. So we put all our models in Lambda, and we handle it with SQS. That is a service for queuing, where it's handled all the inference requests that is made from the backend, for example. So as a conclusion, what we did is we made the development faster. We put everything to serverless and scalable infrastructure, and we succeed to reproduce and to govern all the machine learning parts. In this way, we give a lot of free time to our data scientists, but they didn't want to mix other research or work about models. They went to play ping pong. So we missed the next steps that we need to work on is the feature store, because for this moment we made the make data set in the code, and each time did the same consuming time. So we needed to put it outside, and for this reason we need to make a feature store. But before making the feature store, we need the data engineer that will help on this task. So for this reason, we're looking for data engineers. So if you know some data engineers, it would be awesome to help us on this task. And that's it.
That was brilliant. Thank you so much. We have many questions, and we have time for that, so we can make it. So first is, how do you do feature engineering? Do you have a feature store? That was probably already answered, isn't it?
How we did?
How you do feature engineering?
It depends about each project. So each project have its code, and the major part of the code is running on Airflow. So it depends about the data engineers and data scientists how we choose to make this part. The important things for us, like machine learning engineers, is the pipeline should be scalable, and with minimum of management of the servers.
Another question is, what do you do to avoid spending time automating things that are not needed or are going to be deprecated in the future? That's the question, isn't it?
For the moment, we have all of team of business analysts. That's each time we have like a new version of data from the client. From evidently, it sends notification if the distribution of data changed automatically to the business, and the business made the task to check the data and see if exactly there is something that is missing, and the email the clients to make the correction.
I think this might be a general interest. Someone asked, there's a Paramount learning resource about MLOps. Do you have anything to suggest, I think, was the question, about...
to learn about MLOps.
MLOps, both YouTube playlists, online courses, GitHub projects.
It depends about the cloud provider, because it's important. But maybe the best advice is to learn by doing. So just start from some books. I have this book that can be a good step. Also in references, I made some blogs that show you how to start using MLOps in the AWS platform for the cloud. But maybe learning by doing and start from MLflow with simple projects is the better solution.
On the note of learning by doing, do you know any GitHub projects where you can experiment MLOps life cycles?
I'm sorry?
So the question is, do you know some GitHub projects where you can experiment with MLOps life cycles?
Yeah, there is a lot of tools in GitHub, and there is also a lot of solutions. One of them is the solution of DVG, that they have also some technologies that do the same.
Is it the one for data version control?
Yeah, but they have also the machine learning part. Okay. But it's not free. It is
paid. There's another question asking you, can you do inferencing on GPUs? And does ECR support GPUs inference? Sounds like a heavy Docker container.
For our case, we don't need to make GPUs in the inference part because it's not required. GPUs is used when you need to be really fast on the training part. But for the inference, we need only to make, or to use spot inferences from Amazon that reduce the cost to 90% less, or to use Lambda, for example, that costs nothing, if we can say.
There is another question which is very technical and asks you, how do you spot potential local minima in Kaizen ML?
How?
How do you spot local minima?
So, with MLflow, we can not log only metrics and parameters. We can log also artifacts. Artifacts, it can be anything binary. Image, file, HTML file, JSON, anything of this kind. So we use the log of artifacts to log the SHAP values and to log also the ROC curve and everything that's need data scientists, that help the data scientists to make the decisions that say, this is the best model. In our case, we don't use a lot of artificial networks model because we understand that it's not exactly the right solution for the structured data that we have. Maybe for some projects that they don't have structured data, for example, image or maybe text. But in our case, we use only SHAP values and ROC curves to make the decision.
And then we have a very last question, which is, I guess, a very quick one. How do you control cloud cost? Do you have how do you control cloud cost? I think when you're having
cloud cost.
Cost,
the
billing.
Okay, the cost is handled by the DevOps team. So we have a budget, and in our case, the use of kind of this architecture, it costs you nothing. For example, in this case, we pay 60 euro by month. In this architecture, 14 euro per month. And in this case, maybe 0, because if you don't reach 10,000 requests from Lambda, it is free. So it's about 100 for each project we have. We have 6 business core solutions, so it's about 600 euro.
That makes sense. Brilliant. Thank you so very much for your talk.